This is lesson 65, BHDL example 40, D flip-flop with asynchronous clear and set. This is similar to the previous example, except that in this case we're just going to add a set for the input. So we got clock, clear, set input, D in and Q out. So in the sensitivity list now we'll have clock, clear, and set. So we'll say if clear equals 1, Q gets 0. That's our asynchronous clear. Else if set equals 1, then Q gets 1. So that's an asynchronous set. Anytime set goes to 1, Q will immediately go to 1. Else if. Now this is where we had our function rising edge of clock. But notice that I've replaced it with clock tick event and clock equals 1. This will indicate a rising edge of the clock, and this is the form we're going to use from now on anytime we want a rising edge of the clock. Tick event means there's an event on the clock. It means clock changes either high to low or low to high. So if I say clock tick event and then I AND it with clock equals 1, this means there was a change in the clock and it ended up at a 1, which means it was a rising edge. If I had said clock equals 0, then we would have had a falling edge. Clock tick event and clock equals 0 would represent a falling edge. So clock tick event and clock equals 1 means rising edge of the clock. So if clear is not 1, so Q gets set to 0, and if set is not 1, then we check to see if it's a rising edge of the clock. If it is, then Q gets D, which is our edge-triggered D flip-flop. So this is how we will implement an edge-triggered D flip-flop in BHDL with set and clear. Let's look at the simulation. Here's the clock. If set goes high, the output Q immediately goes high, no matter what clear is doing or no matter what the clock is doing. It immediately goes high, and it stays high until the next rising edge of the clock. Well, on the next rising edge of the clock, Q gets D. Since D is 0, it goes back to 0. Then on the next rising edge of the clock, at this point D is 1, so Q goes to 1. But now we're going to bring clear high. This is our asynchronous clear. Doesn't matter what the clock is, it's low here. When clear goes high, Q immediately goes low. Clear goes to 0, and it stays 0 until the next rising edge of the clock. Notice there was a rising edge of the clock here, but clear is still 1. So when you take away clear, you wait till the next rising edge of the clock. In this case, Q goes to 1 again because now D is 1. On the next rising edge, D is still 1. So Q stays 1. On the next rising edge of the clock, D is 0, so Q goes back to 0. So this is the simulation for our D flip-flop with an asynchronous clear and an asynchronous set.